All right, when you're in this applications of linear models and it talks about regression analysis, regression analysis is actually used to make predictions to see if you have a good linear model. There's a couple of ways for you to figure this out, and I'm going to just kind of show you. This isn't just based on this one problem, but I'm going to show you a couple of ways because it says use your favorite statistics software package. If you don't have Excel, I will say Excel is probably the best one to use, and the reason why is almost every computer that you're ever going to work on, make that bigger for my blind eyes, almost every computer you will ever work on will probably have Excel. Okay, so Excel's good to learn, but I'm going to show you a bunch of different ways to do this. So I'm going to see if it'll let me copy this data. No, it doesn't look like. It would have been nice if I could have copied it. So what I'm going to have to do is type this data in, and it's nice to have these labels. So we have a year, we have a graduation rate percentage, and you can widen cells by just clicking and dragging like this. And so I have what, 2015, 2016, 2017, 2018, how far am I going? Just to 2019. I promise I type faster than this, I just can't see my keyboard right now. All right, and so here I have 77, 80, 85, 88, and 91. All right, so I have some data, and I want to graph it first, so I can simply select it, go to Insert, and we want one of these scatter plots. Definitely looks very linear. And then from in here, there's some things you can do. You can find R, which is the correlation coefficient. You can find R squared, which is the coefficient of determination. And you'll see in your reading that the correlation coefficient, when it's close to 1, okay, so this measures how strong your linear relationship is between these two variables. The coefficient of determination tells your variability in your data. So we can do this pretty quick in Excel with equals C-O-R-R-E-L. Open a parentheses, get the year, comma, the graduation rate. The order that you highlight these on this one doesn't matter, because I'm going to do another example and something like that's going to matter. So I hit enter, and as we figured, this would be very close to 1, because again, if you're close to 1, that's a very strong positive correlation. Means as the years change, as the year is changing, so are the graduation rate in this linear formation. Now here, R squared is just simply I did an equal, click on that cell, and just square the value. And that's pretty much it. Why Excel's kind of nice, and if you have the newer Excel, if you don't, you could probably right click, is you can do this plus, and again, if you don't see the plus, you might have an older Excel and we'll need to do the right click on the data. I go to trend line, more options, and here are some options, linear, moving average, and all of that. But look right here, this display equation on chart, and then display R squared. If you look at this R squared, that's that value. So a lot of times students won't even do this over here because this is the value. Also, what are these other values? Well, this 3.6 is the slope, and the y-intercept is what, -7177, which really has no meaning this is just plummeting. But how you could use this, so this is the equation, y equals mx plus, in this case, -b. You can use this to make a prediction. So I can say, well, what if I want to predict, let's say the year, let's just go to the next year, 2020. I could do this by taking my slope times my year plus my y-intercept, and it'll make it negative there. And I hit enter, and that looks pretty good because that looks like that would be the next prediction. So this is how to do all of this in Excel. In your project, you're actually learning to use Desmos, and there's nothing wrong with it either if you don't have Excel. Need to put our table data in here. Now, so nicely, I believe this I can copy and then paste. Ooh, I went to the next one, so let's get rid of that one. There is our, it was so nice, they zoomed to fit my data. I'm scrolling my mouse in and out, okay? So if you want to see this x-axis, however you want to do it, you could scroll in and out. And then it tells you in your project to do this y tilde mx plus b. All right, sorry, y1 equals this tilde mx plus b. Now, the thing to notice when I deleted that first table, notice it made a second table, so I actually need to rename these x1 and y1 and make that x1. All right, so this is actually from the instructions right here in your project. Okay, so for the linear. If you notice here, and let's bring my Excel back up so we can kind of see some things. The 0.9908 coefficient of determination, 0.9954, that is certainly my correlation coefficient. I can see the slope, 3.6, and minus 7177. So you could see you could use either one of these. There's even, if you go to docs.google.com, and on the left, you tell it to do sheets, a blank spreadsheet, and I think I have all that pasted in there. Yeah, so I pasted my information in here. I can do the same thing, or I can insert. Notice in here you have, different things, however you want to insert. I just did insert a chart, so it did a line chart. Right away, you have the choice if you want to change this into a scatter. And you can kind of go through all these different choices that you have, but if you go to customize and then series, you can see that I can do the same thing where I can add a trend line. Look at there. I can show my R squared. They did a little bit of rounding, but you can still do the same with the slope and the y-intercept. And this is also Excel equals slope. Now this one, the order matters. Notice it tells you data y first, comma, data x, close the parentheses, exactly the same way in Excel. 3.6, my y-intercept is just intercept, my y values, comma, my x values, and then enter. This is just a nice quick way that when it tells you to use, your favorite statistics software package, and you're like, but I don't have a favorite one because I've never done this. I'm gonna always suggest Excel. So all my examples will show Excel, but I'll also show like the Desmos, since that was the instructions. These were the instructions that you were given in your project. So I hope that helps, and happy graphing.